for release with MacArthur monitoring in the cupola. If you are just joining us, we are live here in the International Space Station Flight Control Room with a live view of the Northrop Grumman Cygnus cargo vehicle in the grasp of the Canadarm2 robotic arm. This morning, we're bringing you live coverage of the release and departure of Cygnus from the International Space Station. Today's release is being controlled by ground controllers here in Mission Control Houston. Teams here are being led today by Flight Director Adi Bulos, who has recently taken a go-no-go poll for flight controllers around the room for release. He's joined on console by capsule communicator Scott Sigati. You'll hear calls from Scott to the station crew from time to time today as teams go through procedures for Cygnus's release. Today's visiting vehicle officer is Thomas Castleberry. He'll be communicating directly with Northrop Grumman's flight controllers in Dulles, Virginia, relaying vehicle status and updates back to the teams here in Mission Control Houston. And leading the team in Dulles, Virginia, is Northrop Grumman's mission director, Paul Brower. Teams in Dulles are keeping tabs on the Cygnus vehicle and will take full control of the spacecraft once it crosses over the approach ellipsoid. The approach ellipsoid serves as an imaginary boundary around the station that is referred to as the neighborhood of the International Space Station. The approach ellipsoid governs all vehicles coming or going from the orbiting laboratory. So once again, once Cygnus departs the neighborhood this morning, joint operations will end and Northrop Grumman teams will take full control over the spacecraft. The release window is set up to open around 11:23 a.m. Central Time today, putting Cygnus on track for an on-time release around 11:30 a.m. Central Time. Earlier this morning, flight controllers here in Mission Control Houston used the space station's Canadarm2 robotic arm to unbolt Cygnus from the Earth-facing port of the station's Unity module and maneuver the vehicle into its release position, where it sits now. Cygnus's journey to the International Space Station began on February 20th when the spacecraft launched from the Wallops Flight Facility in Virginia. The Antares rocket lifted off to the International Space Station carrying about 8,000 pounds of science, research, crew supplies, and vehicle hardware. Cygnus arrived to its capture point 2 days later on February 22nd with NASA astronaut Mike Hopkins at the controls of the Canadarm2 robotic arm for capture. A few hours after capture, Cygnus was installed to the Earth-facing side of the station's Unity module, where it had stayed for 127 days. Each Cygnus spacecraft is named after an influential individual in the world of spaceflight, and this Cygnus cargo spacecraft for this resupply mission to the space station is dedicated to NASA mathematician Katherine Johnson. Johnson, a black woman, broke through the barriers of gender and race, calculating orbital mechanics for some of the first U.S. human spaceflights. During her 35-year career at NASA, she calculated the orbital mechanics and trajectories of various U.S. missions to space, such as Alan Shepard's first mission to space and John Glenn's first flight to orbit. Katherine Johnson died on February 24, 2020, at 101 years old. There will be a couple milestones today after Cygnus's release. The first milestone will come when Cygnus departs the Keep Out sphere, which is an invisible line about 200 meters from the International Space Station. After Cygnus departs the Keep Out sphere, the next milestone will be when it exits the approach ellipsoid, or the neighborhood of the station. Once Cygnus exits the neighborhood, joint operations will end and Northrop Grumman teams will take full control of the spacecraft. Our coverage will end there, but its mission won't. After departure, Cygnus will begin its secondary mission, deploying a series of CubeSats. Cygnus will deploy 5 Cube satellites, including the Ionosphere Thermosphere Scanning Photometer for ioneutral studies, or IT spins, which will add to researchers' fundamental understanding of Earth's ionosphere, and the Khalifa University Students Satellite 2, or MySat 2, which will train graduate students through the development and the evaluation of its software. Cygnus will end its journey disposing of nearly 7,180 pounds of trash during its fiery re-entry into the Earth's atmosphere over the Pacific Ocean on July 1st. Again, standing by now for confirmation Cygnus is ready for release, with MacArthur monitoring in the cupola.
Station Houston on 2, back with you, Megan. You are go for Cygnus configuration checks in step 2 of 1.602.
Copy, step 2 in work. Houston Station, Cygnus configuration checks complete. Crew is ready for release and departure.
Copy that. Thanks, Megan.
And there you just heard Meg MacArthur confirm that Cygnus is ready for departure. We're looking for an on-time departure today at 11:30 a.m. Central Time. We're currently in a loss of signal where satellites are switching. We'll have signal back shortly. You're currently seeing a live view of the control room in Dulles, Virginia, where Northrop Grumman, Paul's Brower, is directing this mission. Teams in Dulles are keeping tabs on Cygnus vehicle and will take full control.
We are go for Cygnus Departure on time. You can perform steps 3 and 4 in procedure 1.602.
We go on time, steps 3 and 4 in work.
The release window opened up at 11:23 a.m. Central Time today, putting Cygnus on track for an on-time release around 11:30 a.m. Central Time.
ISS thrusters are inhibited and ground M1 is go for release on time.
Copy.
If you're just joining us, we are live here in the International Space Station Flight Control Room with a live view of Northrop Grumman's Cygnus cargo vehicle in the grasp of the Canadarm2 robotic arm. This morning, we're bringing you live coverage of the release and departure of Cygnus from the International Space Station.
Proceeding with release, Megan. Release commanded.
Copy, I see it.
Snares open. Begin monitoring for drift out.
The snares are now open.
Proceeding with back away.
And has exited the lee.
And release has been confirmed at 11:32 a.m. Central Time as Cygnus and the International Space Station were flying 270 statute miles over southern Wyoming. We're getting a live view from the Canada Arm 2 of Cygnus, now backing away from the International Space Station.
Copy.
We are now standing by for confirmation that Cygnus has started its 3-minute departure burn, which will move the spacecraft a safe distance away from the station, outside the approach ellipsoid, where joint operations will end and Northrop Grumman teams will take full control over the spacecraft. You are now getting a live view of the International Space Station Flight Control Room, where flight controllers here and Mission Control Houston just released the Cygnus cargo spacecraft.
Back away in progress.
Copy. And Houston looks like greater than 4.5 meters of clearance. I'll send the depart command.
Copy, Megan.
We are now standing by for
Cygnus Depart commanded. Farewell to the SS Katherine Johnson.
Copy, Megan. Depart commanded. And as we say farewell to the SS Katherine Johnson, we want to extend a big thank you to the crew and ground teams across the world for all the hard work, and extend a big congratulations on the completion of yet another successful Cygnus mission.
Great words, Houston. We concur.
Cygnus Departure burn is in progress. Monitor departure burn in step 5 of 1.602.
and we have confirmation the spacecraft's 3-minute departure burn is underway. Again, this
Is complete.
Houston, I did not copy your last.
Just letting you know, back away is complete, Megan.
Copy.
This burn will move Cygnus a safe distance away from the station, crossing over the approach ellipsoid, which serves as a mythical cone around the station, considered the neighborhood of the International Space Station. Once Cygnus departs the neighborhood, Northrop Grumman teams will take full control over the spacecraft for it to begin its secondary mission of system tests and CubeSat deployments spanning over the next couple of days. We're now standing by for departure burn to end. Ground controllers here in Mission Control Houston reporting performance is nominal so far.
Let's go on 2 for ICF troubleshoot.
We are with you on 2, Aki.
Again for your go on step 1.
You've got to go.
And Megan, on Space to Ground 2, an offer, we can take control of the cameras if you like.
You can have the cameras.
Copy, will do. And Megan on 2, Cygnus Departure burn is complete. You go to perform step 6 in 1.602. And FYI, Cygnus has exited the 200-meter keep-out sphere.
Copy step 6 and understand exited the keep-out sphere. Thanks.
We have confirmation the departure burn is now complete, and that was Capcom Scott Sigati confirming Cygnus is now outside the keep-out sphere, followed Again, the keep-out sphere exit is one of the milestones built into Cygnus's departure today. Cygnus has now completed the first of 2 of the milestones. We are waiting on the exit of the approach ellipsoid today. If you're just joining us, we are watching live coverage of this departure, the release and departure of the Cygnus spacecraft today, dubbed the SS Katherine Johnson. So far, Cygnus was released from the Canadarm2 robotic arm at 11:32 a.m. Central Time, as the International Space Station and Cygnus were flying 270 statute miles above southern Wyoming. It then conducted a 3-minute departure burn to move a safe distance away from the space station, and Cygnus is now heading toward the final milestone of today, the approach ellipsoid. Once Cygnus crosses over the approach ellipsoid out of the vicinity of the International Space Station, joint operations will end and Northrop Grumman teams will take full control over the spacecraft. Until then, NASA astronaut Megan McArthur will continue to monitor systems from the cupola on board the International Space Station.
With you on 2, Mark. Go ahead.
For the TOCA closeout, the TOC is 446, the TIC is 1003, and the TOC RSD is 3%.
Copy. Tick-tock and tick-tock again. Thanks, Mark.
After Cygnus departs the approach ellipsoid, or exits the approach ellipsoid, it will begin a secondary mission where, once it's a safe distance away from the station, Cygnus will deploy 5 cube satellites, including the ionosphere thermosphere scanning photometer for ion neutral studies, or IT spins, which will add to researchers' fundamental understanding of Earth's ionosphere, and the Khalifa University Satellite 2, or MySat 2, which will train graduate students through the development and evaluation of its software. Cygnus delivered about 8,000 pounds of science, research, crew supplies, and vehicle hardware to the International Space Station on February 22nd. Of that 8,000 pounds was about 2,500 pounds of science investigations. One notable investigation sent up on this mission was a device to measure muscle strength in worms to test whether decreased expression of muscle proteins is associated with decreased strength, which could support development of countermeasures to help maintain crew member health. A good portion of research aboard the station is dedicated to understanding how the human body adapts and thrives in microgravity. There's also a great deal of parallels between health challenges in space and different ailments back here on Earth, with some space-based treatments translating directly to help people on Earth. The International Space Station continues to serve as an essential test bed for people on Earth and in orbit as we continue to move forward, placing the first woman and person of color on the moon by 2024, and eventually onto Mars. Again, we're standing by for confirmation that Cygnus has crossed the approach ellipsoid. Again, we're standing by for confirmation that Cygnus has crossed the approach ellipsoid.
And Station Houston on 2, Cygnus has exited the approach ellipsoid.
Station copies.
And that was Capcom Scott Sigati confirming Cygnus is now outside of the approach ellipsoid, meaning Cygnus has now left the vicinity of the space station. This is the point where joint operations end, and Northrop Grumman teams will take full control over the spacecraft. Northrop Grumman's mission director, Paul Brower, and team will now take full control over the spacecraft. Recapping the events from today, earlier this morning, flight controllers here in Mission Control Houston used the space station's Canada 2 robotic arm to unbolt Cygnus from the Earth-facing port of the station's Unity module and maneuvered the vehicle into its release position. With Megan MacArthur monitoring in the cupola, Cygnus was set free at 11:32 a.m. Central Time as the International Space Station and Cygnus were flying 270 statute miles over southern Wyoming. Cygnus then conducted a 3-minute departure burn to move a safe distance away from the station. Seconds after the departure burn ended, Cygnus exited the keep-out sphere about 200 meters away from the International Space Station. The final milestone came just a minute ago when Cygnus crossed over the approach ellipsoid, leaving the neighborhood of the station, where joint operations ended and Northrop Grumman teams took full control over the spacecraft. Once far enough away, Cygnus will begin a secondary mission deploying 5 cube satellites. After orbiting Earth for a few extra days, conducting system tests and CubeSat deployments, Cygnus will end its journey disposing of nearly 7,180 pounds of trash during its fiery entry into the Earth's atmosphere above the Pacific Ocean on Thursday, July 1st. With Cygnus now safely departed from the vicinity of the International Space Station after its 127-day stay, that'll wrap up our release coverage for today. Be sure to tune in to the Progress 78 launch coverage today. Our coverage will begin around 6 p.m. Central Time, 7 p.m. Eastern Time. We're looking for a launch around 6:27 p.m. Central Time, and docking coverage will begin on July 1st, beginning around 7:15 p.m. Central Time, for a docking at 8:02 p.m. Central Time. Thank you for watching. This is Mission Control Houston.
Yeah, you want to torque it though?
Oh, we got it tight.
The goal of the El Niño Rapid Response Experiment is to look at how changes in the weather patterns, the evaporation of moisture in the tropics, how that has changed during a major El Niño event like the current one out there, and then to look at how those changes further impact the weather on the west coast of the United States. My name is Gary Wick. I'm a physicist with the Noaa Earth System Research Laboratory Physical Sciences Division in Boulder, and I'm on assignment to the Unmanned Aircraft Systems program within NOAA.
Boy, that was the easiest we ever did it.
During this campaign, we have 4 instruments on board the Global Hawk aircraft. The first is a drop-sonde system, which it deploys these very small sensors, much like weather balloons that go up, but these go down. So these small sensors, they're about the size of a paper towel roll, and as they fall, they collect very high resolution, vertical resolution measurements of temperature, humidity, and wind speed. So they give us a very detailed picture of the atmosphere.
Yeah.
In addition to that, we have the HAMSR, which is a microwave sounding instrument, and that provides sampling much like one of the weather satellites that is used extensively in our weather models. The third instrument is HIRAP. It's a Doppler precipitation radar. So just like the weather radars on the ground, we're flying a radar on the aircraft which gives 3-dimensional coverage of precipitation, of rain droplets, and with information from those rain droplets, we can derive continuous measurements of the wind speed in the atmosphere. The final instrument is the Noaa Ozone sensor, which provides measurements of ozone concentration at the flight level of the Global Hawk. The Global Hawk provides amazing capability for this experiment just in its ability to be airborne for up to 24 hours or more. That by being aloft for that long, we can sample a large range of the ocean, almost like a satellite does. That with the Global Hawk, we get very detailed sampling like an aircraft, but with the endurance that a satellite would give us. So we're able to sample this large area and look at changes in the atmosphere that wouldn't be possible with other traditional manned aircraft.
My name is John Newhouse. I'm a Deputy Project Manager for the NASA Global Hawk program. I'm actually a commissioned officer with the NOAA Commission Corps. I've been flying the Global Hawk here at NASA for 4 years as an aircraft commander and instructor pilot. So as you can see here, the Global Hawk has no yoke or stick to fly with. We use a mouse from takeoff to landing, climb and descents when we're underway. Everything is automated in the Global Hawk. So all I need to do is do a mouse click here on the screen to say takeoff or to land, climb, descent, maintain an altitude. Everything is done by this mouse click. And it's very much like flying an autopilot in a manned airplane. And what NOAA is using this is as a study to use unmanned aerial vehicles over high-impact weather events such as hurricanes, and in this campaign we're actually using it over El Nino events in the Pacific. We're going to be working with Air Force C-130s, we're going to be working with NOAA Gulfstreams, and also a NOAA ship, the Ronald H. Brown. So we've got C-130s covering one part, G4 covering another part, the ship covering other stuff, and then we're going to be in the parts that are harder to reach.
We typically take off at first light so we can get to the area of interest to study El Nino weather per the science requests. This usually takes about maybe 8 hours to transit to the area that we're studying. And once we're there, we spend several hours analyzing all kinds of weather phenomena that has piqued the interest of the scientists. And it usually takes about 8 hours to bring the plane back home. So that gives us about a total flight time of 24 hours for each sortie. I'm Herm Posada, and I'm a UAS research pilot here at NASA Armstrong Flight Research Center, and I fly the Global Hawk for airborne science. While we're flying the aircraft, we're monitoring many screens. Mostly we're looking that we're on the right track that science has requested us to fly on. We are also obviously looking at various parameters of the aircraft, make sure we don't get any trouble with airspeed, altitude, or the heading. The flight plans continuously getting updated as science changes the area of interest. Obviously these storms are moving and we are trying to keep up with them.
Hey, mission payload.
So in the Global Hawk Operations Center during a flight, we're going to be monitoring the flight with this wonderful mission tool suite capability that NASA has developed. And with that, it allows us to see the data coming in from the aircraft in real time, satellite data, and multiple things for us to really see what's happening as we go along. And so what we'll be watching for is, can we see the weather patterns? Can we see patterns in the humidity that let us know that we're sampling the areas that are eventually going to move downstream and impact the U.S.? The Global Hawk is a one-of-a-kind capability that, Noaa, we have a great observing system from satellites to aircraft to ships, but there's nothing that provides the capability of the Global Hawk. So within Noaa, we really want to see if that is a really good addition to our current observing system. And so by collaborating with NASA, we get this wonderful opportunity to test its capabilities, see its impact on the forecasts, and then hopefully that opens the door for a broader collaboration down the line to do this on a regular basis.
Copy, and release will be in any right turn away from you.
This is a story about heat. Heat in our atmosphere, our oceans, and land. When you think about it, events like droughts, hurricanes, and fires, all of those are just different ways we see heat expressed throughout the Earth system. You've probably been bombarded with a lot of intense headlines in 2020. Hottest temperature recorded here, largest wildfires there. It's been a lot to take in. My name is Leslie Ott, and I'm a research meteorologist at NASA's Goddard Space Flight Center. So the reality is the stage was set many years ago for these events. Over the last century, human activities have increased the concentration of greenhouse gases in our atmosphere. These gases act like a blanket, trapping heat and leading to overall warming of the planet. Many of these gases remain in the atmosphere for a long time, meaning that we'll be feeling the consequences of this trapped heat for many years to come. Which unfortunately means next year is probably going to bring a lot of the same kinds of stories that we saw in 2020. But taking a look at all the different ways our planet responds to the variations in movement of heat can help us better prepare for the future. Maybe one of the most obvious ways that we saw heat this year was through fire. I know the Australian bushfires were big news last January, and when you think about it, years of prolonged hot temperatures and drought really set the stage for these fires to be more likely and more severe. With drought and heat waves, we typically see an increase in the availability of dry fuels, which leads to more powerful fires. So when you have multiple years of intense heat, it's not surprising to have significant fire events like we saw in Australia. These fires were so extreme that we saw smoke injected as high as 18 miles above the surface. That's really important because when smoke is injected that high, it can have the same type of effect as a volcano, having these very, very broad impacts across whole hemispheres of the planet. At NASA, we use computer models like the Goddard Earth Observing System to help us study how aerosols and particulate matter move through the atmosphere. So we take these models, we input real-world observations and data to track fire emissions to help understand how they're forming, where they're going, and how much of an impact they'll have on you and me. In California, heat waves have increased fire risk, and as a result, we saw a lot of synchronized fire activity. That is, many dangerous wildfires burning at the same time. And unfortunately, these types of huge fire events are becoming more and more common across the western United States. And that's a big problem. This year, course, Siberia also had a remarkable and active fire season. What we saw was that temperatures in the region were much higher than normal for this time of year. In fact, the temperatures above the Arctic Circle broke records in many of the same regions where the fires were burning actively. In the Arctic and boreal forest ecosystems, heat waves can exacerbate fires. And in the Arctic, you also have to factor in permafrost, which is soil that's frozen for long periods of time, and that can make the impact of fires in high latitudes even more complex. When severe fires burn in areas with permafrost, we lose this important insulating organic soil layer, which accelerates thawing, and it's potentially releasing carbon that's been stored in the soil for hundreds and in some cases even thousands of years. And you sometimes see these zombie fires, which happen when wildfires burn deep into peatlands or smolder in forests under snowfall. If that temperature doesn't get cold enough to extinguish the fire, they can continue to burn over the winter, even long after the visible fire's been extinguished at the surface. So come spring, they reemerge and they continue to burn back on the surface again. Studying what happens in the Arctic is really important because it's warming about 3 times faster than the rest of the planet. And all those aerosols and the carbon that come out of the Arctic don't necessarily stay there. They affect the heating and air pollution in much larger regions of the planet. Another part of the planet affected by heat, of course, is ice. Land ice in the form of ice sheets and glaciers where we've seen significant melt in recent decades, and frozen ocean water, or sea ice. This year, the Arctic sea ice minimum almost reached a new record low. It was second only to 2012's extent, which was an anomalously low year in part due to unusual weather conditions. Sea ice shrinks and grows with the seasons. After reaching an annual minimum extent in September, Arctic sea ice begins to grow again as sea temperatures cool off for the winter. This year, Arctic sea ice had an unusually slow start to the regrowth period. In particular, the Laptev Sea, which is sometimes called a sea ice nursery because much of the Arctic sea ice initially forms there, was too warm for meaningful sea ice growth until much later in the season than usual. Oceans absorb heat from the sun, and our atmosphere prevents this heat from escaping back to space. The movement of this heat is one of the primary drivers of circulation and global weather patterns. We can measure the temperature of the ocean, and what we saw this year was unusually high surface temperatures across the Atlantic. The warm moisture that comes off the ocean acts as fuel to storms. So as this layer of the ocean gets even warmer, we're seeing that storms are becoming more and more intense over time. In fact, 2020 sea surface temperature contributed to an exceptional year in terms of Atlantic hurricanes. We saw 30 named storms, a new record, and 12 of these storms made landfall in the US. What's really interesting is that many of these storms intensified really rapidly. Not only are storms intensifying more quickly, but what we're seeing is that they're stalling near coastal regions more often, which is devastating in terms of floods and storm surge. While we're not 100% sure what is causing these storms to stall, it may have to do with climate patterns shifting in response to rising global temperatures. It's always really tough for a scientist to say any particular fire or any particular event was because of climate change. But we're getting to a point where we're starting to see season after season of record-breaking wildfire, season after season of really intense storms, that it becomes much easier to understand that this is likely the result of long-term climate change. In general, more heat means more energy in the Earth's system. So while 2020 was a significant year, it's important to know that this probably wasn't an anomaly of a year. We're likely to experience many similar years as the Earth's climate gets warmer. So while we saw a small dip in emissions this year due to COVID shutdowns, it was pretty short-lived. The vast majority of our greenhouse gas emissions come from things like electricity generation, which were less affected by the shutdowns than emissions from cars and airplanes. But we know that human activities have a powerful impact on our environment. Long-term strategies to curb human-induced climate change would have to focus on implementing cleaner technologies so we can reduce emissions without affecting people's daily lives. So while this is a story about heat, this is also a story about connections. Nothing in our planet happens in a vacuum, and our actions today impact our tomorrow. The choices we make now can make the difference between continued increases in greenhouse gas emissions and 2020 being the year that they peaked.
Spacewalking astronauts work outside the space station. NASA's new deputy administrator is sworn in and putting another piece of our Artemis 1 moon rocket in place. A few of the stories to tell you about this week at NASA. On June 25th, astronauts Shane Kimbrough of NASA and Thomas Pesquet of the European Space Agency conducted the third spacewalk in 10 days outside the International Space Station. The pair worked to install and deploy the second of 6 new ISS rollout solar arrays. The arrays will help increase the station's total available power and are the same solar array design that will power elements of the agency's Gateway lunar orbiting outpost.
I, Pamela Ann Melroy.
On June 21st, former astronaut Pam Melroy took office as NASA's new deputy administrator after being given the oath of office by Administrator Bill Nelson in a ceremony at our Mary W. Jackson NASA headquarters building in Washington.
I'm very honored to be teamed with Administrator Nelson and our Associate Administrator Bob Cabana and the rest of the broader team. It's our intention, I believe, to not just lead today's NASA, but also lead us forward into the future and support the generations of fantastic things that NASA will continue to do.
What a grand occasion for us, and what an appropriate nominee, now confirmed. And so we've got someone that is extremely skilled, experienced, and ready for this job.
Melroy was nominated in April by President Biden and confirmed by the Senate on June 17th. She is one of only 2 women to command a space shuttle and logged more than 38 days in space as an astronaut. Workers at our Kennedy Space Center have stacked the launch vehicle stage adapter atop the Space Launch System or SLS rocket's core stage ahead of the uncrewed Artemis 1 moon mission targeted for later this year. The cone-shaped adapter connects the core stage and the interim cryogenic propulsion stage, which provides the Orion spacecraft with the additional thrust needed to travel tens of thousands of miles beyond the moon. Artemis 1 is the first integrated test of Orion and SLS ahead of missions to the moon with astronauts. After several months of checkouts and calibrations following its launch last November, the ocean-observing Sentinel-6 microfreilich satellite made its first science data available to the public on June 22nd. The satellite is a U.S.-European collaboration to measure sea surface